Module 4, Lesson 17. Objective: relate decimal and fraction multiplication. Here's another problem. Here we have 0.01, also read as 1/100th times 6. Let's write that in fraction form as 1 over 100 times 6, or we would be thinking of 1/100th of 6. Let's think of that with a place value chart. 1/100th of 6. What is it that we would do? We have 6 in the ones place. How many places would it move? And which direction? Is it going to get larger or smaller? The digit doesn't shift to the tens place. That would be 1/10th of 6. It will shift all the way over to the hundredths place, or 6/100ths. Writing 6/100ths as a decimal, that would be 0.06. If we work out our multiplication here, 1/100th times 6 is 6 over 100, which does equal 0.06. So we're relating that fraction with that decimal equivalent. Those things have an equal value. Let's take a look at two expressions that are actually very similar. Here we have 3 times 5/10, and then here we actually have 3/10 times 5/10. 3 times 5/10, let's rewrite this as a fraction of 3 times 5 over 10, and then we can evaluate it. The next step from there would be 3 times 5 over 10. And 3 times 5 is 15 over 10. That's 15/10. And then how do you write 15/10 as a decimal? Right, 1.5. Let's work through this next one here. That's 3/10, write it as fractions, times 5/10. And our next step here is 3 times 5 over 10 times 10. 3 times 5 is 15. 10 times 10 is 100. And then so in this case, you have 15/100ths. And writing 15/100ths as a decimal, that's 0.15. In comparing these two, you'll notice that we have pretty much the same digits. But these digits here are shifted over one more place, because we're looking at 3/10 of 5/10 versus 3 5/10. Let's look at 3 more expressions and let's evaluate them. We have 1 6/10 times 3. Let's write that back in unit form this time as 16/10 times 3, which also would be 16 over 10 times 3, which also is equal to 48/10. If we work that out with that standard algorithm, where it is that I had broken it apart or multiplying by whole numbers, we would have gotten that same type of answer where it was 48/10. And 48/10 is written as 4.8 as a decimal. So we have 48/10 here, we have 4.8 there. 1.6 times 0.3, that's also 1 6/10 times 0.3, that is. So that's 16 tenths times 3 tenths. You can also think of that as 3 tenths of 16 tenths, or 3 tenths of 1 6/10. So that should be smaller than 1.6. In fact, it's only 3 tenths of that 1 6/10. So let's see what it looks like here. That's 3 times 16 again, which, as before, we got 48. And then we have 10 times 10, which is 100. So we have 4800, which is 0.48 in decimal form. For that final one, we have 0.16, also read as 1600ths. Let's write each of those out as a fraction. So we have 1600ths, and we're still multiplying there, and it's 3 tenths. 16 times 3, just as before, still 48. And 100 times 10, you add another 0 to the 100, and that's thousands. 1,000. So that's 48 thousandths, written as 0.048. So although we have many of the same digits, their value is different because they are in different places. Okay, you try. Write them out as multiplication expressions, including fractions, and then evaluate them and write them back in decimal form. Pause that video while you're working these out. What did you do for the first one? Did you write 7 tenths times 3 equaling 21 tenths? Or did you listen to me and say, oh, Mr. Yen said to write it with a fraction, and wrote 3 times 7 tenths to get 3 times 7 is 21 tenths, and 21 tenths in decimal form is 2.1. So 3 times 7 tenths is 2 1/10. For our second one, writing them each out as fractions, that's 3 tenths there, 7 tenths there, and we multiply them. The numerators, 3 times 7 is 21, and 10 times 10 is 100. So I have 21 over 100, which is also 21 hundredths, which in decimal form is 0.21. Be very careful where it is that you're placing those decimal points, because the value of each of those different digits is going to be very different. For that final one, should have had 3 hundredths, 7 tenths for those two fractions. We multiply those together. 3 hundredths times 7 tenths. 3 times 7 is 21. 100 times 10 is 1,000. So we have 21 over 1,000, or 21 thousandths. Writing that as a decimal, there needs to be a 0 in the tenths place, and then you have a 2 and a 1. Check over your work. Here's one final problem just to show you this approach one more time. We're looking at 0.9 times 0.8. Let's write them both out as fractions. We have 9 tenths times 8 tenths, and we do not simplify these fractions. 9 times 8 is 72, and 10 times 10 is 100. The reason we're not simplifying these is because now we have 100 in the denominator, and I can just read this as 72 hundredths. If I had simplified it, then I would get something else in the denominator, and it would not be as easy to write it into that decimal form. So I have 0.9 times 0.8 equaling 0.72. Thinking of this again, this is 9 tenths of 0.8, or 9/10 of 8/10, so it makes sense that it should be less than 0.8. And the fact that would be 90% of it, or 9/10 of it. And the way that we approached this is that we approached it using fractions and then wrote it back as a decimal so that we can know these decimal equivalents for these fractions.